Hello, today I'll be showing you something called something that I've made that is something called a matrix, and most of you probably know that. So I'm going to share the code in the description so that you can use it too. So let's get started. And you can see that today I'm using Jupyter Notebook. And the reason I'm doing that is because I wanted a quick way to update to Python 3.7 from Python 3.79, which is the version I'm working with, to Python 3.97, and it was actually pretty easy. In Jupyter Notebook, it's 3.97, and to prove that I made this small thing, which will give you out and show you that it is 3.97. So let's get started. I have this whole kernel here, and I just want to see something. If I can just do this, I'm pretty sure I can. Wait, let's try something. Wait. I just want to see if this works. Okay, so it works. Are you ready? And let us start. So here is my code for matrix, very small amount, but it is a good library if you're into more representations or something. So matrix is not really a math library, even though it uses the matrix in math. It is more for representing a matrix. So to make your own matrix, you can say, and I'll be showing you how the code works. You can say D equals, or let me just call it, math. So math equals our matrix. And here we're going to put in some lists. So 1, 2, 3, 1, 2, 3. And now I'm just going to print you out how math looks like. And you see how we get out our printed answer. And even though this might be like, oh my gosh, that is the coolest thing in the whole entire world, it's not really, because matrix, and also matrix will use matrix. The fundamentals of matrix is that you have a matrix, which means that you can't go around doing this. Now you kind of can for the first and the last array. So you can say 1, 2, 3, 4, 5, 6, and it's out there. But it only works for the last. So if you try doing that here, it will be a broken system. And if you try doing it in the middle, it would be even more broken. So you don't want this syntax, this code syntax. You want every single thing to be the same way. And I'm going to give you a better version of matrix that already checks for this. So if you do it, it's bad. And maybe actually I'll add that feature in the episode. But now let's start going on. So you can see this print math is all it's doing is calling the string dunder method. And that's like the per dunder method, except for per, which I'm going to call it representation. So for the representation dunder method, it's more for like giving you a discrete representation. So say first order, just for other developers. And like if it's a more codical thing, like a file, you'll give all the file details, so like speed and all that stuff. And then string is more for like when you turn your matrix into a string. And if you don't get what I'm saying, if you say a string matrix, so remember I'm using the dunder method, and I print a. Oh, oops. I say math equals string matrix. Oh, so let me just do is there. So mat equals string mat, print mat, and you'll see the same thing come on. So the string and the print are essentially the same. Now let's get on to a big question. If I have string and if I have wrapper, how does Python know which one to use? So let's go here and let's look. Let me make a class. Now this is like an everything episode. Let's just like kind of touch on everything we've done. So I'm gonna make a class. Test. It doesn't have anything inside of it. Nothing unless it puts itself in it. So nothing inside of it. The only methods it has is wrapper and string. So let me just make this wrapper method. And what it will return, is string. Wrapper. And now I'll make my string method. And it will return string. So now, what are you guessing? I am guessing, I actually didn't try this before, so I am guessing string, because that's a more discrete one. Let's see. So, let's say A equals test, and I am guessing for string, I don't know. Submit shows the representation. Let's see. String. Okay, my guessing was correct. Because wrapper is more for a developer standpoint. If I had this file class, it will give me like the time, the speed, the access, which means that the mode, so R or W, and all those stuff. And string will just give me a way to convert it. So I'm just going to cancel all this out, and usually you should have a string and wrapper, so your wrapper would be what it basically is, your program, and then your string will print it out. So now let's go back to matrix, and Jupyter has a cool coloring convection. I usually don't have all of these, like enumerate with some blue in my atom. So let's continue on. So math equal to matrix. Now I can also do this. So I can make matrix 1, 2, 3. For I in math, print I. So we have 1, 2, 3, and we can do this again. So 1, 2, 3, and we'll get 1, 2, 3, 1, 2, 3. And this is a iterable. I don't think I talked about iterables, but they cannot be exhausted. So actually, I didn't talk about all the things in here. I didn't talk about iterators yet. But what an iterator is that, let me just make a class iterator. This is going to be a long episode. Class iterator. Wait. So an iterator is basically, in short, a way to iterate over something. So something that you can iterate on, but it isn't a data structure. Now some data structures can be data structure if they have iter, but they also have something called get attribute. And that's an example of, get item. That's an example of, I think, list, because get items for sequence types. So I think the only things that are iterable and are data structures are sequence types. So get adders for that. And but they support iter. It basically just returns out the same thing. So you might not get what I'm saying, but let's say I make a list. Now, I can get an element for a list, or I can use a.getAttr. So a.getItem, I can also get attr, is a dunder method. And if I want to get item number 1. And don't be fooled, this is not saying get, if you find item number 1, this is saying get the item at the index 1. And just start in a variable. Now if I print D, I get 2. So that makes sense. And now for the iterator, if I say a dot, if I just wait, yeah. So now what I'll do is I'll do something kind of confusing. I'll say a dot next, and a dot next is what makes it an iterator type. If I print this, let's just run that. Oh, wait. First I need to do this. And what this will do is that it will give me out something called an iterator. So you can see it was an iterator object. If I just print out A, it won't give me iterator object, nor it will give me something else. It will just give me a list, but this is actually an iterator object. A is what's called an iterable, which when you pass iter into it, it will give you an iterator object. And I won't talk about iterators too much. I mean iterables, like this is the only time we're going to talk about iterables. And I won't talk about iterators too much in this episode. So I just wanted to go quickly, or else this is going to be a very long episode. So now I'll call b equals a dot iter. It'll give me an iter object, so a list iterator object. And what I can do is that I can go to B now, because it's an iterator, and just print I. And this prints out 1, 2, 3. But the thing about the iterator is that if I try doing it again, it will just print out 1, 2, 3, and everything else will be exhausted. So that's part 1 for this episode, and I will see you later for part 2.